Jai Hind everyone, myself Rekha Baghel. Welcome to the lecture series on cloud computing. Subject code is KCS 713. Myself Rekha Baghel, Assistant Professor Ajay Kumar Garg Engineering College, Ghaziabad. Today's topic of this lecture is NIST Cloud Computing Reference Architecture. So in this lecture, we will discuss about the basic knowledge about the NIST cloud computing architecture, then how this what are the different important components of this cloud computing reference architecture in detail. So NIST cloud computing reference architecture, basically this reference architectures is used for providing the basic description of the framework for developing the applications. So this is the template which can be used for the different development, and this template description of the architecture is defined on the various levels of abstractions. So this abstraction can be of high level or low level. If we talk about the high level abstraction, this high level abstractions show the different functionality provided by the applications. So this high level abstraction provides the different functionality at the high level, and low level abstraction. So this low level abstraction provides the different methods. What are the different methods which are provided by the application is defined or shown in the lower level. So we can say this NIST cloud computing reference architectures is the abstraction of the functionalities and the methods performing the specific task. So this model, this cloud computing reference architecture is also called the conceptual model. So this conceptual model discusses the technical requirements and the operations of the cloud computing. Or we can say cloud computing architecture, this NIST cloud computing architecture is the blueprint for so it is a blueprint to guide the developers in design of various applications and services. Without this NIST cloud computing reference architecture, there are many other reference architectures, but with the help of this cloud computing reference architecture, we can develop the applications. So understanding the requirements, using characteristics and standards of cloud computing architecture. So we can use this NIST cloud computing reference architecture to understand the requirements of the users and the uses of the applications, characteristics and standards of the cloud computing. So it is a very important NIST cloud computing reference architecture for developing the applications and developing the services for the customers. And for exam perspective, it is a very important topic. You can easily understand this NIST cloud computing architecture after watching this video. So this is the main architecture. So basically in this NIST cloud computing architectures, there are the main 5 components. So these 5 components are known as the actors. So basically actors, what are the actors? Actors are the some individuals or the organizations which have specific functionalities or which has the defined functionality. So every actors have their own defined roles and responsibilities. So in this diagram, there are the mainly 5 components. What are these components? Or we can say there are 5 actors. 5 actors. So first actor is cloud consumer, Second actor is cloud auditor. Third actor is cloud provider. Fourth actor is cloud broker, and the last actor is cloud carrier. So we can say there are the 5 main components of the cloud computing. So you can see here, these are the 5 main components of the cloud computing reference architecture. First is consumer, second is cloud provider, third one is cloud broker, fourth one is auditor, and fifth one is carrier. So with the help of these 5 actors, this computing architecture is designed. So cloud consumer basically acquires or uses the service. It is the user of the application or service. Cloud provider is the vendor of the services. Cloud provider basically provides the services. Cloud broker works as the intermediator between the consumer and the providers, and basically they provide the services to the consumer and contact to the provider respect with the services. Auditor is basically independently perform. It basically check the services whether they are conforms with the expectations or the promises given to the consumers, and it assess the cloud services. Carrier is basically, it provides the connectivity and transport of data and services between the providers and consumers. So these are the mainly 5 components which can be be used as the main components of the cloud computing reference architectures. These 5 actors have the specific roles and responsibilities for performing specific tasks. So this architecture, so these are the 5 components. So if we talk about in detail, so this cloud consumer is a person who uses the service, and this is the cloud auditor. The task of cloud auditor is to audit the security that is provided by the cloud provider, privacy impact audit, and performance audit. So these 3 tasks is audited by the cloud auditor, and this is the cloud provider. So cloud responsibility of the cloud provider is huge. So this cloud provider provides the various functionalities like service orchestration, cloud service management, security, privacy. If we talk about the service orchestration, so service orchestration is provides the different functionalities like at the level of service layer, software as a service, platform as a service, and infrastructure as a service. And next one is resource abstraction and control layer, physical resource layer at the level of hardware and facilities. So these are the functionalities provided by the service orchestration. Cloud service management, cloud provider have the concern about the business support, provisioning and configuration of the resources, portability, interoperability. So these are the different functionalities provided by the cloud providers. So next one is cloud broker. So cloud broker is basically work between the cloud provider and the cloud user, cloud consumer. So basically this cloud broker uh, uh, contact between the have the contact between the cloud consumer and the cloud providers. So cloud consumers faces the difficulty if they directly buy the services or buy the softwares from the cloud providers directly. So despite of creating the softwares, these cloud providers contact these cloud brokers, and the cloud consumer also contact with the cloud brokers. So both the parties contact to this cloud broker, and the cloud consumer uh, uh, gives the brief idea about the what are their requirements and which type of services they needed. And this cloud broker is a third party which provides the services by contacting to the cloud provider and sells these services to the cloud consumers. So the main task of cloud broker is service intermediation, service aggregation, and service arbitrage. So these are the main functionalities of the cloud broker. So cloud consumer, now we will discuss all these parts one by one. First is cloud consumer. So basically there is a catalog, in which all the services are mentioned provided by the cloud provider. So basically if a cloud consumer needs any service, it browses that catalog and find the basic description about the services mentioned in the catalog, and according to need he search particular service. Now when he browses the services from the service catalog, the next step is the cloud consumer requests the services depending on the activities performed by the cloud consumer. He and the user scenario, he requests this service to the cloud consumer or cloud broker. So cloud consumer can purchase the services directly from the cloud provider or from the cloud broker. So next, after request sent to the services, request sent to the service provider or the this broker. Next, there is a contract between the provider and the broker. So if this cloud consumer purchase the service from the cloud broker, still there is a contract between the cloud consumer and the cloud provider. So this contract is basically served as a document that describes the promises made by the provider to the consumer about the particular service, and the this contract, the expectations are mentioned by the cloud consumers. So this we set up the service contract with the providers. So this service contract may be built upon the build for the service. So for software as a service, so there is a billing process. For billing process, there are different billing process for software as a service and infrastructure as a service and platform as a service. So for software as a service, consumers may be billed based on the number of users, time of the use, net bandwidth, storage volume. So these are the different criterias for the billing. When we talk about the infrastructure as a service and platform as a service, the consumers may be billed according to the processing storage, network resources, number of virtual machines, HTTP calls, number of IPs used, net bandwidth, and storage volumes. So there are different criteria for billing for the software as a service, platform as a service, infrastructure as a service. So these criterias are mentioned in the SLAs. So SLA is This SLA is very important part for the this computing reference architectures. So SLA, the full form of SLA is service level agreements. So basically, when we talk about there is a contract between the cloud consumers and the cloud providers. This SLA perform their task. So it is very important role play by the SLA. So consumers need the service level agreements to specify their performance requirements to be fulfilled by the provider, and the SLA in which the cloud providers mention the services provided by its means promises made by the cloud providers. So they basically it is not negotiable, means in generally we mention that it is negotiable, but the cloud provider does not negotiate about the cost. If he mentioned some cost to the for the particular application, so that is fixed. So service level agreement, SLA, it is a important topic. So SLA is the contract. So this SLA is the contract that are negotiated and agreed between the provider and customers. So to locate reserve resources to satisfy consumers and consumers requirement with efficiency and optimality resource and services users. So basically SLA is nothing but it is a contract between the consumer provider and the cloud consumer and the cloud provider. So it is negotiated, but as I already told, it is not negotiable. So to guarantee an agreed SLA, the auditor must be capable of measuring and monitoring relevant metrics. So when the cloud provider provides the services to the consumers, so there is one actor that have a specific responsibility to measure the performance provided by the performance of the service provided by the cloud provider, so that it can check, it can apply the checkpoints on the cloud service provider. So the cloud auditor basically provides the have the some specific performance measures to measure the performance of the services provided by the cloud provider. So there are different SLAs must be considered for infrastructure as a service, software as a service, and platform as a service. As of now, we don't have the clearly measurements, performance measurements for software as a service and platform as a service. We in today's scenario, we have the clearly mentioned SLAs for infrastructure as a service only. So these basically these are the SLAs for infrastructure as a service. So these are the parameters on which the cloud auditor checks. So for example, the performance check is on CPU capacity, means CPU speed for virtual machines, how much CPU speed is given by the virtual machines, memory size, cache memory size for virtual machines, boot time for the virtual machine to be ready for the use. So these are the different parameters: storage, scale up, scale down, scale up time, scale down time, and availability. And this is the description of these parameters. So all these parameters have some numerical values when these infrastructure as a service used. So if we are, for example, CPU capacity, CPU speed for virtual machines. So this parameter must be mentioned in some numerical values from the cloud providers. So the cloud auditor check whether this service that mentioned in SLA is actually provided by the cloud provider or not. So this is the task of cloud auditors, to apply the checkpoints on the cloud providers. So cloud providers, basically cloud provider is the main person which acquires and manages the computing resources or computing infrastructure. So it runs the cloud software, makes services available to the interesting parties. So main task of cloud providers to develop the services, develop the applications and provide these applications and services to the cloud consumers. So these cloud provider makes the necessary arrangements or contracts with the consumers. So these cloud providers can also list the promises that he will make to the consumer or limitations and obligation that customer must accept in the SLA. So providers pricing policy and SLAs are not negotiable in most cases. So whatever the price he has mentioned in the SLA is the final price for the service. So these are the 5 main activities of the cloud provider: service deployment, service orchestration, cloud service management, security and privacy. Cloud auditor is the person who audit the services provided by the cloud consumer, provided by the cloud provider, and it's basically cloud auditor have the contractual clause. It works as a third party, and it is worked on the SLA made by the cloud provider and check the SLA. Cloud broker is the intermediary between the cloud consumer and cloud provider. So integration of cloud services by consumers can be too complex. So rather than purchasing the services from the cloud provider, the consumer ask the cloud provider to provide the services and directly purchase the services from the cloud broker. So it is a third party, and these cloud broker provides the services in 3 forms: intermediation. First is intermediation, second one is aggregation, and third one is arbitrage. So intermediation presents the services to the consumers, and by adding the identity management, performance reporting and enhanced security. Aggregation means it combines and integrates the multiple services into one, and arbitrage means arbitrage means the services being aggregated may change or come from the different providers. So this is all about the NIST cloud computing reference architecture. Thank you.